Now, another type of indices question that may be asked is a solving question. So we have two types of solving. Let's just start with the first one, where it's a very straightforward comparing exponent kind of solving, which means that we must try to make such a way that the left-hand side and the right-hand side of the equation will have the same base. Alright? So now, in this case here, what we see that this is 4 and this is 16. And this is a subtraction here. So some of you may be wondering, does this mean that I have to use a substitution? That will be something that we are going to do later. Actually, we don't have to. So what we can do is that we can bring this term over to the right hand side. So we have 4 to the power of x squared minus 6 equals to 16 to the power of x plus 1. Alright, and why do we want to do that? It's because I'm going to force the right hand side to also have the same base as the left hand side, which is base 4. And it can be done because 16 is the same as 4 squared. So on the left hand side, I don't make any change, but on the right hand side, 16 is the same as 4 squared. Alright, by the law of the indices, which is the third law, I could actually expand this out and I will be able to have it as 4 to the power of 2x plus 2. And what you realize is that on the left hand side we have a base 2, on the right hand side we have on the left hand side I have a base 4, right hand side I have a base 4, which means that now I can equate the exponents. Now I'm not cancelling the base, okay, I'm just equating the exponents. So I can say that x squared minus 6 must be the same value as 2x plus 2. Bringing all terms to the same side, I will have x squared minus 2x minus 8 equals to 0. And of course, we can actually do a very simple factorization. So we have x negative 4 plus 2, because negative 4 times positive 2 is negative 8. And we will be able to have it as x minus 4 can be 0, or x plus 2 can be 0. Solving for x, we have 4, or x can be negative 2. That's it. Alright, so by comparing exponent. Now, then there's this other type when we can't make them the same. Alright, like for instance, in this case here, I have a subtraction, I have an addition. So no matter what I do, I will not be able to use the law of the indices to make them have the same base on the left and the right hand side, unlike the previous example. So what I need to do now is that I will need to use a form of substitution. So what I have to look carefully now is that I have to look, okay, I have 9 and 3. 3 is the smaller one of the two, right? So which means that 3 to the power of x, this will be my substitution that I'm going to use later on. So what does it mean? It means that I have to change this to somehow have a base 3. And this is what I can do. 9 is the same as 3 squared. Now for this one here, I'll just write it again as per normal. And by the third law of indices, 3 to the power of 2 bracket power of x, I can just sort of like change places because it's actually a multiplication. So 2 times x or x times 2 is the same thing. So I'm going to write it as 3 to the power of x instead. Alright, so the 2 goes out. Now, why do I want to do that? It's because I want to use a particular substitution. So since I have 3 to the power of x here and 3 to the power of x here, I'm going to say let u be 3 to the power of x. It's just that, you know, it makes it a lot easier to look at, alright? So whenever I see 3 to the power of x, I'm going to put it as u. So there's a square here, so that's why this one is u squared. Now, then I have 28 over 3, and don't forget, this one I want to replace as u as well, and I have a plus 3 here. Alright? Now, I have a fraction here. Let's multiply by 3 throughout. So I will have it as 3u squared minus 28u plus 9 will give me 0. So I see that I have a quadratic. So what can I do? I'm going to use my factorization. So I have 3u and u. Then I can have 1 and 9. Okay, so I'll be able to solve for u, which is 3u minus 1 equals to 0. So u will be equals to 1/3. Or I could have u minus 9 equals to 0, u equals to 9. Now remember, we are trying to solve for x because originally there was an x. We are not solving for u, so do not stop here. Don't forget u was used just to make it simple, right? And u is supposed to be the same value as 3 to the power of x. So this is what we have. Alright, now 1/3 is a reciprocal, so I can write it as 3 to the power of -1. So what does it mean? When I compare the exponents, so x is actually the value of -1. But I could have another case here as well. U could have also been 9, so which means that 3 to the power of x could have been 9, which is 3 squared, and again comparing the exponent, x is equals to 2. There you have it. So we have using substitution to solve when we cannot use the law of indices to combine them.